All right, so in this problem, I'm going to look at the window problem. So we'll do slightly different numbers, but let's say somebody watches a ball fly down past a window, and it takes uh, 0.17 seconds for the ball to pass through the field of view of the window. And if we measure the window, let's say the window is 1.85 meters tall, right? And we wanted to know from what height was the ball dropped, right? So how high above the window was the person that dropped the ball, right? So our question is really this. All right, but we don't really know a lot about what's going on up here. We know we want to know displacement. If the person drops it, we know the initial velocity is 0 meters per second, right? For the entire scenario, something's flying through the air, so we always have that. That's negative 10 meters per second squared, right? But for up here, really what we need to solve for D would be V final, right? So we would need to know what the velocity is at this location. So we could use Vf squared equals V initial squared plus 2AD. But we don't know that. So is there some way we could figure out the velocity here using this information down here? And the answer is yes. So we have D for displacement. We have this D. We have this T. And in this half of the problem, we're actually treating this like the initial velocity because that's where it starts to fly past the window, right? So we're going to use the equation D equals V initial T plus 1/2 AT squared, saying that V initial is the velocity at this location, which would be the V final for the next part of the problem. So all we have to do is plug in. Now remember, we're going down 1.85 meters, so that's going to matter, is equal to, and the initial velocity, I'm trying to solve for that, T is 0.17, and then plus 1/2 of negative 10 times 0.17 squared. So let's see what I get here. 0.17 squared times 10 times 0.5 gives me this. It's actually a negative number, right? But we're going to add it over here to this side, right? So we'll say add to 1.85 negative. And then I will divide by 0.17. And so I get the initial velocity right at that location is negative 10 meters per second squared, which makes sense, right? Because, or sorry, not squared, just negative 10 meters per second. And that makes sense because it's going down, right? So it would make sense that the velocity is negative. So now I'm going to look at the top half of the problem, where instead of this being V initial, now this is actually V final in the top problem. And we're going to use Vf squared equals V initial squared plus 2AD. And we dropped it, so this whole term is going to cancel out. So we're going to get negative 10 squared is equal to 2 times a negative 10 times D. So I get 100 equals negative 20D. So if I divide by negative 20, I actually get the displacement is going to be negative 5 meters, meaning that the ball was actually dropped from 5 meters above the window. Okay, so important things to note about this problem is that we can define what the variable means for different parameters. So being able to separate this into two separate parts and changing what the velocity or what variable the velocity is in this equation is important. So for the second part, it is V final, but for the initial part, it is V initial. All right, so hopefully this will help you solve the window problem on the constant acceleration classwork.